All right, this is Dubious Code looking at project Euler number 9. I think this is going to be a fun one. So we have a Pythagorean triplet. So a squared plus b squared equals c squared, and they're all three integers. And the famous one is the 3, 4, 5 triangle. So this would be 3 squared plus 4 squared plus 5 squared equals 25. 3, 4, 5 triangle, the one you may have seen before. But we want the biggest, there's exactly one Pythagorean triplet for which a plus b plus c equals 1,000. Find the product a, b, c. So the constraint here that we need to do is to set a plus b plus c equals 1,000. So we'll start with a at 1 and then vary b and c such that they equal, the sum of everything equals 1,000, and then find out if they match. So that's not so hard. I think it's basically another brute force one. So let's see, we set a at 1. Let's see. We'll loop through a. Loop through b. Loop through c, and then b equals loop through b, and then c equals 1,000 minus a minus b. C must be greater than a and greater than b. That'll be a quick check. And c squared equals a squared plus b squared. If this is valid, then we're done. So I guess a can go up to 499. Maybe just call it 500. I in range 1 to 500. So we'll call this b, or a. For b in range 1 to 500. C equals 1,000 minus a minus b. Answer equals 1. We'll start with 0. Answer equals 0. If a times a plus b times b equals c times c, answer equals a times b times c. Break. All right, brute force all the way here. Is there anything we could be doing smarter? So this is an n squared problem. It's only n squared up to 500, so it's, let's see, 25,000 operations. I think I could probably handle that. Let's test it and see if we can get the 3, 4, 5. So 3 plus 4 plus 5 is 7 is 12. So we'll test this up to 6, 6, 12, and see if we can get the answer for 3, 4, 5. This is project order 9. So I just did 8, I'll do 9. Unexpected indent. Ah. Sometimes it's, I'm using Sublime, and sometimes it weirdly doesn't save for me. There we go. Okay. 3, 4, 5. 4, 3, 5. Ah, okay, so it breaks out the inner loop but not the outer loop. We will, instead of breaking, we'll return. And that is 60. Okay, so we want 500, 500, and 1,000. $200, $375, and $425. Ah, the classic. Every school child should know that one. All right, let's see if this works. Problem 9, done. This is Dubious Code. Thanks for watching.